Properties and state of a substance. If we consider a given mass of water, we recognize that this water can exist in various forms. If it is a liquid initially, it may become a vapor, then when it is heated, or solid when it is vapor when it is heated, or a solid when it is cooled. Thus we speak of the different phases of the substance. A phase is defined as a quantity of matter. A phase is defined as a quantity of matter that is homogeneous throughout. When more than one phase is present, the phases are separated from each other by the phase boundaries. In each phase, the substance may exist at the various pressure and temperature, or to use the thermodynamic terms, in various states. Now, in each phase, the matter may exist at various pressures and temperatures, or to use thermodynamics terms. In various states. The state may be identified or described by a certain observable macroscopic properties. The state may be identified or described by certain observable macroscopic properties. Some familiar ones. So we have a definition of a state here and properties. Some familiar ones are temperature, pressure, and density. Temperature, pressure, and density. In later chapter, other properties will be introduced. Each of properties of a substance is given a state has only one definite value, and these properties always have the same value for a given state, regardless of how the substance arrives at the state. In fact, a property can be defined as a quantity that depends on the state of the system and is independent of the path. In fact, a property can be defined as any quantity that depends on the state of the system and is independent of the path. By which the system arrives at the given state. Conversely, the state is specified or described by the properties the state is specified or described by the properties. Later we will consider the number of independent properties a substance can have, that is, the minimum number of properties that must be specified to fix the state of the substance. The thermodynamic properties can be divided into general classes, intensive and extensive. Dynamics properties. We have intensive properties and extensive properties. And intensive properties is independent of the mass. The value of the extensive properties varies directly with mass. Thus, if a quantity of matter in a given state is divided into two equal parts, each part will have the same value of intensive properties as the original and half the value of the extensive properties. Pressure, temperature, and density are examples of intensive properties. Pressure, temperature, and density are examples of intensive properties. Mass and total volume are examples of extensive properties. Extensive properties per unit mass, such as specific values, are intensive. Specific values, such as specific weight, specific volume, or specific, for example, energy, or these are the intensive properties. Frequently, we will refer not only the properties of a substance but also to the properties of system. When we do so, we necessarily imply that the value of the properties has significance for the entire system, and this implies the equilibrium. For example, if the gas that composes the system in the control mass in the thermal equilibrium, the temperature will be the same throughout the entire system, and we may speak of temperature as a property of a system. The next subsection is process and cycles. In a mechanical equilibrium, there is no tendency for the pressure at any point to change with time as long as the system is isolated from the surroundings. There will be variation in pressure with elevation because of the influence of gravitational forces, although under equilibrium conditions, there will be no tendency for the pressure at any location to change. However, in many thermodynamics problems, this variation in pressure with elevation is so small that it can be neglected. Chemical equilibrium is also important and will be considered in Chapter 16. When a system is in equilibrium regarding all possible change of state, we say that the system is in thermodynamic equilibrium. Anyway, the next section is process and cycles.